All right, guys. Sorry I couldn't be there today. Welcome to your final season. It is called Statistics. Now, in Statistics in IM1, you didn't talk much probability. There was a little bit of some probability trees and some sample spaces, but we're really going to dig into probability big time in IM2. So without further ado, jumping on in, the first question is as basic as probability can get. Think about flipping a coin and you've got heads and tails. Okay, think about the outcome that could possibly happen when you flip a single coin. Now, if you were to have two coins, think about what would happen if you flipped coin number one. We'll call that first coin. And then after that, when it lands and there has been an outcome determined, you flip coin number two. So we've got two coins here, both fair coins, heads on one side, tails on the other. Now think about it. I've color coded this. First coin is in blue. Second coin is in red. Now, before we can answer the questions based on probability, we need to first create what's called a sample space. Now, this thing right here, this is what is known as a sample space. A sample space shows all possible outcomes for an experiment. So when we flip the first coin, and we've color-coded that blue, if we land on heads, that is now established. Now, when you flip the second coin, there's the possibility of heads as well, or you could flip tails. So these are the two possibilities after you flip the first coin and it lands on heads that could possibly be your outcome after the second coin is flipped. So you could go heads, heads, or heads and then tails. Now this second row here, it's kind of like a Punnett square, right? If the first coin lands on tails, your possibilities for the second coin could be heads or it could be tails. So you could go heads, heads, you could go heads and then tails, or if the first coin that you flipped landed on tails, you could go tails, heads, and then tails, tails. These are all of the possibilities. There are only four. So very basic, very simple, four possibilities, and you can see them all listed in the sample space. Now soon we're going to get to probability as soon as your homework that comes up in the next couple nights here that have possibilities of in the thousands, 10,000, 100,000s. So sample spaces are not always going to be realistic, but we introduce probability by creating sample spaces just so that you can see all of the possible outcomes. But if you can imagine listing 100,000 possibilities, it's not possible. Millie needs me 1 second. Okay. Millie had to show me what dress she planned on wearing. All right, so back to work here. So using the sample space and what you know about probability to answer each question, what is the probability of a heads-up result for flipping the first coin? So we call that probability of A, or we could even just call it probability of heads, okay, on the first flip, probability of heads. It's just 1/2, okay? It's a 50-50 chance. So we say 1/2 or 50%. Very, very simple. B, what is the probability of a tails up result for flipping the second coin? Now, the second coin flip is completely independent of the first coin flip. So because the first coin landed on heads, it doesn't mean that the second coin you flip has to land on tails. They're independent events of each other. So the probability of a tails up result for flipping the second coin, that's also going to be 1/2. Okay, it's still 50-50. Okay, it's 50%. All right. Now, C, what is the probability of a heads-up result for the first coin flip and a tails-up result for the second coin flip? So this is what's called probability of A and then B. So we can go probability of heads and tails. Okay. Now, the first coin flip has to be heads, and the second one has to be tails. Now, if you look at your sample space, that happens one time out of the four possibilities. Okay, so we are going to say that that is 1/4. One out of the four possibilities is heads first and tails second. So that's going to be 25%. Okay, now lastly, what is the probability of a heads up result for the first coin flip or a tails up result for the second coin flip? Now this is a little bit different. Okay, whoops, 1 second, let me get rid of this thing. Okay, now if we're saying or, let's go probability of heads or tails. Okay, so we have to think about all the successes here. So probability of a heads up result for the first coin, well, let's see. A probability of a heads up for the first coin That happens in a couple of different places. Let me get a different color here. We'll go blue. So heads up on the first coin, that's this box and this box. Okay, that takes care of 2 possibilities. Now, what also is considered a success here is if there is a tails on the second flip. Okay, so that's going to be this guy right here. The only one that doesn't work is this guy right here. So if we're going probability of heads first or tails second, that is going to be 3 out of the 4 possibilities, or 75%. All right, so our first big concept here for probability. This is what's called the rule of compound probability with AND. So that states if event A and event B are independent events, meaning that the second flip was completely independent from the first flip, it was not affected by the result of the first flip, then the probability that event A happens and event B happens is the product. So basically you're just going to multiply. And we can test this because check it out. Up here where we did the probability of heads and then tails, if we think about this, if this was the probability of heads, let me get my pen here. This was the probability of heads and then tails. That would be the probability of heads times the probability of tails. Now, what was the probability of heads? It was 1/2. What was the probability of tails? It was 1/2. And recall multiplication of fractions. You multiply across the top. The numerators, 1 times 1 is 1. The denominators, 2 times 2 is 4. And we end up with 1/4. So from this point forward, sample spaces are great. Sample spaces are going to help us determine probability. But 99% of the time, you're going to use this rule. Probability of A and B. Whenever you see and, that is going to be the probability of A multiplied by the probability of B, and that will give you the result. Why can you trust that? We literally just proved it. Look at the sample space with a very simple probability model. We saw that probability of heads and then tails was 1 out of the 4 possibilities. Now this right here demonstrates that we can always rely on the product rule of probability just by multiplying probability of A times the probability of B. All right, now read through learning goals, read through the vocabulary. There's a lot of stuff that you've already seen, such as probability, outcome, sample space, compound events with and or. That's going to be new. We didn't talk about that much in IM1, but let's push forward. So on to example 1, compound events with and or. So we've got a new holiday. It is called Probability Day. It's going to be celebrated at your school, and it will be celebrated on one of the 12 months, but only on the first 3 days. So the problem is to choose which day it will fall on. Now, if you think about it, if it's going to happen on the first, second, or third day of the month, and there's 12 months, that is 36 possibilities, right? There are 36 possibilities here that would work. Now, if we construct a model to represent the sample space for this situation, I encourage you to pause here and try your own. And I'm also going to pause the recording and just wait and see if you can draw on your own. So pause right now. All right, so here's my model. It just represents January, February, March, April, May, June through December. It just shows the first 3 days of each month. So there's 36 possibilities here, right? So what's the probability that each day is chosen at random? So think about like reaching into a bag and pulling out a date. Well, January 3rd, that is this day right here. Okay, and that happens 1 out of 36 possibilities. So that's the probability of January 3rd. May 2nd, that is this guy, January, February, March, April, May. That's going to be this guy right here. Okay, that also happens 1 out of the 36 possibilities. Now, any specific day and month, basically that just says what's the probability of any of these 36 happening? Well, they each have an equal possibility of happening at 1 out of 36. So pretty basic there. Now we are going to roll into calculating probabilities of a couple different specific things. All right, so probability of A is going to represent the probability of selecting a summer month. Okay, so how many months are there in the year? There are 12, right? Now, if we define June, July, and August as the summer months, that would be 3 out of 12. So if you were to randomly select a month, what is the probability that it's a summer month? 3 out of 12, which is equal to 1/4 if you reduce, okay? Now, the probability of B is defined as the first day of the month. Now we've narrowed this down to either it's the first day of the month, the second day of the month, or the third day of the month for probability day, okay? So if we're going first day of the month, well, the first day of the month represents 12 possibilities, okay? We've got them identified right here. Okay, that's 12 out of 36 total possibilities, right? Now 12 out of 36 reduces to 1/3. So the probability of B is just simply 1/3. Okay, now here we go. Here's our test of the product rule that we talked about right up here. The rule of compound probability, okay, with and. So let's see if this works. So if we go probability of A and B, okay, what that's going to look like is this. The probability of A and B, probability of A and B is equal to the probability of A multiplied by the probability of B. So let's just throw these in. So the probability of A is 1/4. The probability of B is 1/3. Now that would equal 1/12. Okay? So let's just see if this makes sense then. So the probability that when we randomly select a day that it's going to be one, a summer month, and be the first day of the month. Okay, that's these three possibilities right here, right? So we've got all three of these days. That's June 1st, July 1st, and August 1st that would satisfy. Now that's three possibilities, right? Out of how many total? That's 3 out of 36. But 3 out of 36 reduces to 1/12. So you can see in our sample space with this picture here that 3 possibilities out of the 36 satisfy 1, that it's a summer month, and 2, that it's the first day of the month. 3/36 reduces to 1/12. So once again, this product rule, probability of A times the probability of B, it works. It checks out. So I know I said we're 99% of the time not going to draw a sample space like this guy and like this guy here, because soon, once again, we're going to have outcomes that are going to be in the tens of thousands, hundreds of thousands, and it's not going to be possible to draw a sample space. But we are still just proving that this formula, probability of A times the probability of B, will work. Okay, but you had to expect that there be something else with this word or. Okay, so it's a little bit different. Now, if we look at the list, or the list just means if we look at our sample space, our image here, okay, what is the probability that we choose a summer month or the first day of the month? So if we count these out, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possibilities, 18 out of 36, which equals 1/2, which equals 50%. Now, how are we going to do that when we've got hundreds of thousands of possibilities in some problems coming up here soon? Well, we're going to have to use this formula right here because it's not always going to be as easy as just counting them up. Okay, so let's test this. The addition rule for probability states that the probability of event A occurs or event B occurs, the probability of A plus B minus the probability of A and B. I know that's weird, but basically what that's saying is this. If we go probability of A, which was the probability of a summer month, that was 1/4, okay, plus the probability of B, which was the first day of the month, that was 1/3, so plus 1/3, okay, minus the probability of A and B, okay, and now we know that A and B, this right here is 1/4 times 1/3, right? So the and formula is kind of hiding within this or formula, and we know that that equals 1/12. So if we go 1/4 plus 1/3 minus 1/12, that comes out to 50%, or 1/2. Now, how the heck did I get that? You'd have to put it in a calculator, or if we just use the unsimplified versions here, so 1/4 was 9/36, right? Was 9/36. So I'll just show you slightly different. So 9 out of the 36 possibilities were right here, okay? So the probability of let me back up here. 9 out of the 36 possibilities were right here. So the probability of a summer month, that was 9 out of 36, okay? Plus the probability of B, that was the first day of the month. So that was 12 out of 36. Okay. And then minus the probability of A and B, we showed that that was 3 out of 36. So if you subtract 3 out of 36 right here, that right there, once again, also gives you 18/36. Now here's the important part here, guys. And here's why we subtract. So when you go probability of A, which is the summer months, you count these 3 days right here, okay? You count them as part of the summer months, but then you count those 3 days again when you're considering the first days of the month. So if you count all these up, that would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But then you're counting them again here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you double count these 3 days, right? Let me highlight these so you can see it a little bit better. You double count those 3 days right here. And because you double counted them, you have to subtract them out right here. You can't count the same day twice. Each day only happens once. So when you consider 9 out of 36 and then 12 out of 36, 3 of those days were counted twice, June 1st, July 1st, and August 1st. So you have to subtract out the overlap, which is why we go minus 3/36, okay? Which results in 18/36. Now again, you can trust this formula moving forward, okay? And why does it work? Well, we just showed it with this sample space and with this image. Okay, so to wrap things up here, looking at example 2, I'm going to post a separate video for this because this is a behemoth of a problem. This is a big problem. Now, I'd encourage you, before you look at the next video for example 2, to try creating and drawing a sample space of your own before you look at mine. Try example 2 on your own, but it's a really good challenge. So good luck with it, and pick up on the second video with example 2 after you give it your best shot on your own.